Hey, Programming 12. We're back with some 3D stuff for you to take a look at. And what we're going to be doing today is we're going to be reading in a image that will represent a map. It'll be sort of a two-dimensional top-down view of 3D space. We'll read that image in, and then we'll make it draw this 3D map that represents it. So I'm in this like kind of rando room here I've created. Excuse me. And I'll show you what the actual image looks like. I'll have to move my mouse. Whoops. Facing the ground. This is the picture here that I drew. I'll try to zoom, but that will... my computer will struggle mightily to open up the magnifier. There we go. Yeah, this is it right here. This is sort of my 2D kind of top-down view. Do you see that? How like that is the world that I had? You can see there's like a little door here. And we have these sort of black looking sort of, I don't know, things in the corners, a green pillar, not quite in the center, and the blue walls. And if I was to go back in here, can you see how this is that floor plan in 3D? Looks reasonably similar, right? So how is it that we can do this? And and by the way, this is something that we've changed. So if I were to make a change, if I was to say, put in another green pillar. No, yeah, okay, whatever, it doesn't matter. Who cares? I'll put in some other green pillar over here. That's not a pillar. I don't know, whatever. It'll suffice. Like you'll see that shape sort of rendered in 3 dimensions. I'll save this, and then I'll zoom out maybe, and then we'll go back and we'll quit this and we'll run it. Sorry, I didn't quite get there. Here it is. So let's run this. And we'll see that shape now appears in 3D, sort of in the floor plan in the right place. Here we go. All right, so do we see 2 green pillars now? Yeah, there's one and there's the other. You can see where I made my mistake too. It's like, it's not square, it's got this sort of Tetris-y shaped look to it. Yeah, see how that worked? So we're basically reading from the map and coming up with the coordinates for where to put these boxes. So I'll show you the code of what makes this work. To start with, I'll go to the very top. I have first a color palette, and I actually don't need this too much, but I do want to know what white is. That color is ignored in my map, right? So if I have this map, I'm ignoring the white pixels basically. That's empty space. So I do need to be able to check what white is. I could have put the other colors in here if I want to do something interesting. So for example, eventually we'll put in like a dirt block where it's brown and diamond block where it's blue and so on. We'll put in like specific kinds of blocks. So then we'll need to have all the colors we want recorded here. So this eventually will become more important. I also have 2 more variables. I have the grid size and the map variable itself. Grid size is very much like in the chess game. We had, I don't remember if it was a variable, we might have just hard-coded that, but it's basically how big is each square going to be. Our map has pixels, so each one of these pixels is 1 by 1, but how big of a box does that create in our 3-dimensional space? So that's what grid size represents. And then the map is the picture itself, and we load that in setup. I have it just here in my setup. I guess I put it at the bottom of my setup. So I did load image, map.png. If you can't draw a PNG, by the way, I can load this as a file for you to access. Then we have grid size. I chose 100 as my grid size. That means the footprint of each pixel will be 100 by 100. So that's the story there. So that's all my setup. And now in my draw function, I've added in a new function called draw map. So it'll basically just loop through our image, going sort of row by row and draw in real time corresponding boxes. So this isn't quite the final product, but it's a good test to see what's going on. So this is the code here, basically just about, other than the braces, like it'll fit onto one screen. So I'll try and stick it here. So we're using a nested for loop. If this is confusing, do let me know. I think that's what we use in our chess project. But basically, we're just going to be going for every x coordinate between 0 and whatever the width of our map is. Mine is 40 by 40, so I could have typed in 40 here. But I wanted to make it more adaptable. So if I put a bigger picture in, it would draw a larger surface. So this is the name of the P image, by the way. That's the name of the P image variable, so it can tell how big the picture is that I've loaded into it. So it's 0 to 40. I'm just going to go up by 1 each time. And then this is the Y coordinate. So going down 0 to the height of the picture, which is, again, 40 for my picture. And then here's what we do. This is a nice little function. A P image can get the color of a pixel at a particular coordinate. So it can get it at X and Y. So it can get the color and it will return it. I'm going to store it in a variable called C. So this is basically me taking a look at a particular pixel. Start at 0, 0, and then it will look at 0, 1. It'll actually go down the column, and 0, 2, and 0, 3, each time checking what the color of the pixel is. And then if it's not white, then it will do something. It'll make a box there. White pixels, as I said, we're going to be empty space, because that's just the default color of pixels in my editor. So I just made that, if they're not white, then do something. If they are, it'll just skip over it. So these X and Y's are just going up by 1. So I need to then multiply it by the grid size. So this is fine. So I do a push and pop matrix to make sure they don't stack on top of each other. And then I'm just filling with the color that I found. This is just kind of a temporary solution. That's why my green pixels make green pillars, and my blue pixels make blue walls, and my black pixels make those black sort of like angly things in the corner. I'm just using that color to color my boxes. Stroke, I've just chosen 100. I don't know. It's no important reason why I've chosen that. And then translate's a little bit crazy. The translate you can play around with for sure. This is not the last thing we'll talk about with translate. We're going to have to modify this a bit. But basically, my top-down map isn't actually X and Y. It's X and Y into 2D, but when I draw this is actually going to be our XZ plane, right? That's the floor. We're looking at a floor plan. The floor is in the X and the Z coming out at you. So I've actually had to plug in the Y coordinate into my Z coordinate. So I multiply that by grid size, and I multiply this by grid size. And then the minus 2,000, let me show you why it's minus 2,000. If I don't put in minus 2,000, it just starts at 0, 0. So my whole world gets built just in that quadrant. It's just into the quadrant 1. So if I run this, it's a little slow. I don't know why my computer's struggling so hard today. Whoa, sorry. We got to solve that problem. You'll notice that my floor is only like a little bit because I've actually built this starting at 0, 0. See where 0, 0 is? So that red line is? That's my axes, right? So like the rest of my floor is over here. And I didn't center it very well. My whole thing is off center. So my floor doesn't match up with my map. So I just shifted over. Literally just shifted it over. I know the dimensions of my floor, so I just did minus 2,000, minus 2,000. Just to kind of shift it into the right space. There's a little bit more I might do here. But that's fine. I wish it wasn't so slow to load. My computer's struggling right now. So there we go. Now it's kind of shifted, so it's the center of the picture lines up with the center of our origin in our 3D space. One last thing to mention, the box. I'm using box, not the textured box that we wrote. So box has a weakness that I'm unfortunately having to program for, and that is this is drawn at the center coordinate. It assumes this is the sort of, it assumes that this translate is the center of the box. So that's why I have to make the box at the middle point. I'm not drawing them at the floor. I'm drawing at the midpoint because it's going to grow otherwise. If I was to draw it at, say, 0, 0, it would be sort of in the roof, but the center of it would be in the roof. I wish I would just run like normal, sorry. Here we go. You see how it's like, now it's impaled, its center point is in the roof? So I'm actually going to put it at the halfway point between the roof and the ceiling, which was height divided by 2, because it grows out from that point. I don't love that. That's why we drew the box, the textured box, the way we did. We drew it at the vertex being in that corner. So that's a bit of a weakness. Otherwise, the box would be grid size by grid size, but I'm going to make it height tall, so it stretches from roof to ceiling. And that's that. That's the story. So I'll put this map file for you on Teams. You could try this, and then I invite you to experiment with changing up that map. Make it more interesting. Make it more complicated. And You could even try to load textured blocks into it too. Maybe green means a grass block. Maybe blue means a diamond block. That kind of stuff. We can start experimenting with adding in different types of textures. Anyways, it looks like it's time for me to go teach math. So thanks so much. I'll talk to you guys soon. Bye.